Welcome back to part 10 of our Arduino CAN bus introduction series. In our last session, we delved into the concept of arbitration, a crucial aspect that will play an even more significant role in future discussions. However, for the present, I'm eager to continue exploring basic applications that hold potential for enhancing model railway layouts. In this video, I'll be sharing two sketches designed to showcase the practical uses of Arduino in the realm of model railways. Specifically, I'll demonstrate how a cost-effective SG90 servo can be employed to move to two distinct positions, 10 degrees and 90 degrees. For this demonstration, we'll utilize the standard Arduino servo library, along with the two previously introduced libraries, spi.h and mcp_can.h. So here you can see the wire connections required to use the MCP2515 module represented by the colored circles, and the servo connection which is represented with the color squares. I tend to swap the single connector on the DuPont wires for the 8-way, 5-way, and 3-way units, and once tested I like to use hot glue to fix them into place for the MCP2515 modules to avoid possible issues when working on the layout. The 8-way one will overhang by one position on the MCP2515 module, the 5-way will have a gap in the center of it. The first sketch we will take a quick look at, you will find in the servo folder of the series repository on GitHub, linked in the description of the video. You will see the two different sketches I am using for this video. We will start with the servo_receive sketch. I will give a brief overview of the changes from previous sketches shown only in the Arduino IDE. I have now added the Arduino servo.h library. You may need to add this yourself using the library manager. This saves us a lot of extra coding later on, to control the SG90 servo. I then add a global const, int, variable for the servo pin and set it as equal to 6 on the Arduino Nano. We then set up a servo object for the servo library and call this my servo. You could call this what you like, but you need to remember to quote the new object name later on. In the void setup function, we now use the servo.h library to set up the pin 6 as our servo pin. This is done by first stating which servo, so, my servo, and we say we use the const, int, variable name we gave it earlier, servo pin. In the void loop function, we first have an if statement to check if we have received a message, and if so we add the data to a CAN message buffer, which we have seen done before. We then have an if statement that checks to see if the message has the following series of data. First, did it have the RxID equal to 0x0123? If it did not, it will ignore the message. If it did match, it then checks if the first data bit 0 was equal to 7. If this is true, it will check if the second data bit is equal to 1. It will then go to the line my servo.write, and this we have given it a value of 90 degrees. It will then print out to the serial monitor the message, servo moved to position 90 degrees. The second if state will look for the second data bit of 0, and if so move the servo to 10 degrees. The second sketch is the servo_send. This is very similar to other send sketches. It is just here to help you to test out the receive sketch. In the next few weeks I will look at making the LEDs and the push button and now the servo flow into a useful project for a layout. Here is the servo working. Thank you for watching.